So I'm delighted to welcome Michael Avant-Smith from BMA to join us for this edition of the Business of AI podcast. So Michael, welcome to the podcast.
Thanks very much, Tim. Look forward to the discussion.
Thanks very much. Well, yeah, it's great to have you here. Let's start off as we always do by finding out a bit more about you. So could you tell us about how you ended up doing what you're doing and what BMA actually does?
Yeah, no, absolutely. So my personal background, I've spent most of my career, started as an engineer, and then moved very quickly into technology. So large enterprise applications to start off with, and then a variety of advanced analytics, and then more recently into the sort of expanded world of AI. But along the way, I've also spent some time, quite a lot of time in infrastructure. So developing large scale projects in the water sector, in the energy sector around the world. So really, I think BMA and my interest in BMA is really around that intersect between AI and infrastructure. It's as simple as it is. At BMA, we focus on infrastructure planning. So that's long-term strategic planning all the way through to operational planning. And that's obviously a complex world. The infrastructure is probably been quite an incremental sector or group of sectors for the last few decades. And suddenly we've seen an explosion driven by all sorts of different tailwinds, obviously energy transition and decarbonisation of the energy system, new demand coming through from AI data centers, new expectations when it comes to water and wastewater management and avoiding pollution in our rivers and waters, and then also more focus on circularity. And that includes everything from waste streams converted to energy through to the recovery of heat and the reuse of that. So a number of different things happening, but we're really at the center of that and leveraging AI to make sense of all the complexity and help align plans across multiple different stakeholders.
Wow, I mean, there's so much happening there, isn't there, in terms
Absolutely.
of infrastructure is key to everything, both businesses and consumers as well. So I'm really keen to dig into this because it sounds like there's two big areas here. There's one which is how AI as an industry requires infrastructure, energy and water in particular, in order to function. But then there's also AI as a solution. So you mentioned that you're using some tools there to actually deal with the complexity of making those infrastructure systems. So I think those are the two areas that I'd love to sort of dive into. First of all, on that sort of the way that AI systems use energy and water in particular, could you maybe sort of share some of the ways that you've seen that whole area develop? I mean, I imagine at the beginning there was a lot of inefficiency in the way that data centers were using both energy and water. Have you seen that sort of evolve and change, and what are the main drivers there?
Yeah, absolutely. I would actually, and we'll come back to this, but obviously we started using AI for infrastructure planning as opposed to focusing on AI infrastructure as the starting point. So maybe that's just a bit of context. So what we see in terms of AI infrastructure and the development of that is really almost been a secondary trend for us, which has obviously amplified what we do. But picking up your points, obviously, AI infrastructure, when you look back 2 years ago, we weren't having this conversation. So this is new stuff, and particularly in the world of infrastructure, this is a massive change. So we've seen the development of that being very tactical. Where's the demand? How do we get kit on the ground as quickly as possible? How do we build capacity? And then obviously look back upstream to say, where do we get the energy? Where do we get the water? What do we do about cooling? Those are probably three big areas. So that's been a sort of new piece of the puzzle for us, but it's just one piece of the puzzle. We've always looked at those systems in the whole, and the interconnection between those systems. So in a way, we've suddenly found ourselves at the center of this conversation. Like everybody else, we don't have the sort of the silver bullet to resolve all these challenges, but what we can do is provide the context, and we can help set out pathways towards moving this from a tactical type conversation into a more of a strategic conversation with longer term planning, but taking into account those near term or immediate actions that need to be taken.
Yeah, that's the challenging thing, isn't it? It's the scale of this change and it's the speed of this change, and then on top of that the complexity of this change as well. All of those things make it really hard. And I think, you know, the nature of infrastructure itself is that it's not something that can happen quickly, because it needs to be built and planned, and there's connections and all those kind of, like, you know, these take many years to go through those processes. So I think this is where then AI powered tools then offer solutions, because they can accelerate some of those challenges, or they can deal with the complexity. So you mentioned that you're sort of focused on using AI powered tools for planning. Can you help us understand what that looks like? Where do you start, and what does a sort of project look like for you?
Yeah, no, absolutely. So maybe again, just sort of rewinding a little bit, you mentioned the importance of infrastructure for social and economic development. So that's a central theme. You know, that hasn't changed. I think what we're seeing with AI infrastructure is just a reinforcement of that. You know, this scramble to effectively capitalize on the economic potential of AI, but also understand the social impacts, positive and negative, of that. So that's that's the very broad context. Then, as you say, you start looking back at the world of infrastructure that has been around for a long time and probably ignored or undervalued for a long time, whether that's water infrastructure or energy infrastructure, because it's been incremental in nature. You know, everybody assumes that when you flick the light switch, the lights come on, or turn on the tap and the water flows. You know, that's pretty much embedded in all our lives. What we're seeing now is this disruption, where whether it's new demand coming through, and this significant demand, that's no longer incremental. So this is suddenly throwing everything up in the air. Combine that with decarbonisation and the pressures around that. Combine that with new expectations that we should be able to swim in any water source and do so safely. You suddenly have new expectations in terms of our water infrastructure as well. So all these things have been simmering up. I think all we're seeing now is this step change in terms of expectations and needs, which is really changing things. One of the things about the infrastructure sectors across all of them that we've spoken about is they are real laggards in when it comes to digital and certainly AI. We're starting from a low base because of that incrementality. We haven't seen the sort of innovation that we've seen in financial services or consumer products that have been doing this for a long time and really leveraging AI more and more. This is much more of a step change between a very low base to a very high base. So that's where we find ourselves, is effectively taking all this vast amount of information that is available, making sense of it in this new world where we have this huge uncertainty around what demand is actually going to look like, what energy transition is going to look like. And we're not talking about, as you said, what it's going to look like next year. That's important, but what is it going to look like in 25 years? And then you throw into the mix, how do we accelerate around AI and ensure that we don't lose the race in terms of building out AI capacity and building sovereign AI to some extent, whatever that looks like.
Yeah. So within those complex systems, then I can imagine that there's a lot of data, albeit you mentioned some of those bigger companies maybe haven't done the digital transformation process. So there's maybe not as much data as we would like, but there must be a lot of data that you're working with. How do you then go from those data sets into being able to optimize for efficiency? Because it sounds like that's the sort of the bit where you're looking at using AI powered tools.
No, absolutely. And as you say, I mean, we can go down the rabbit hole of data and data completeness and data accuracy and all the rest. I personally don't see, based on our day-to-day work, that AI is actually the biggest problem. We do need to continue to improve data, the quality and reliability of that data, more data. But actually, there's a lot of data out there, as you said. The challenge in the sectors we work in is more around how do you surface that in a way that's understandable and people understand those relationships between assets, connectivity, so the pipes and cables that connect those assets, where those assets are located. So there's a massive spatial element to this. What does that mean for environment? What does it mean for communities? So that spatial element is really important. The temporal element in terms of what do you do in what order is also incredibly important. So, we've seen the big discussion at the moment and the huge investment going into electricity transmission. So how do you move new supply from up on the shores of Scotland down to the south where that energy is needed. As you said, you've got to reinforce the transmission network before you can actually move that. So we're seeing some of the disconnects where we're building supply, but we can't actually move it to the right places. So that temporal element in terms of sequencing and aligning different plans, incredibly important. And then obviously there's the financial and economic element to that, of what is this actually going to cost and who's going to pay for it. So, for me, there are many more complexities in there, but it's a spatial challenge, it's a temporal challenge, and it's a financial modeling sort of techno-economic study. So like you said, there's a huge amount of complexity there, but there's actually a lot of data. If you look at what we know about mapping and the data we have there, a lot of it open source. What we have around understanding the actual physical infrastructure, more and more stuff available on open portals from different network operators, which has been encouraged by the regulators. So there's more and more data available. And the problem is combining that into something sensible and then overlaying a suite of AI. And I should stress that we don't see, when we talk about AI, we're not talking just about large language models. That's just one part of it. We're talking about machine learning, predictive models of what may happen under different uncertain conditions. We're talking about optimization, mathematical optimization, to ensure that we actually understand that sequencing. And then we're putting the explainability of how do you explain to a range of different stakeholders why different trade-off decisions are being made and why they make sense for the system as a whole rather than for individual parties, actors within that system. So yeah, hopefully probably overwhelming you already, but there's a lot to think about. And that's the excitement from our side, is just there's so much to do and we're coming from such a low base. And that really is that intersect between this critical infrastructure and the evolution of AI. We're right at that intersect, and that's hugely exciting for us and hopefully very beneficial for our customers and different stakeholders that we're working with.
Yeah, the word which I think was really interesting there was explainability, because I think that's almost the opposite of the complexity, right? So we started off by talking around how complex these systems are and how much data is coming out of them, and all the challenges around that. But then at the other end, you've got a simple human who wants to understand simple things in order to make decisions. I'm simplifying it, but and it feels like that's the sort of the gap you're trying to traverse, going from the complexity to being able to give the simple direction to make decisions.
Yeah.
Can you talk us through how you're sort of using sort of different technologies? And you mentioned they're not all high-end AI powered solutions. Sometimes it might just be basic data science or sort of mathematical process. But can you help us understand how you go from the complexity to the simplicity?
Yeah, so maybe, as you say, it's almost, you can view it as different layers. The starting point is, what is the raw data that you have? What is that availability of data? The next part is actually sort of making sense of how that all connects together. And we have, you can call it a digital twin. It's a variant of a digital twin, but it's that digital representation, that ontology of the system as it stands. So recognizing what the system looks like from a spatial perspective, from a technical perspective, from an economic perspective. So that first layer, as you said, is actually just making sense of all this vast amount of data. Before you start analyzing it, it's really, what do those systems look like? How do those interact? And what are the key aspects within those systems? The next layer is where you start to look at optionality of how do you actually change those systems to meet demand, to ensure that they're resilient, to ensure that they're adaptable. At that stage, you're starting to look at all the things that are done by engineering teams within all these different organizations. They're already working on projects. A lot of those are very good. But what they tend to be doing is looking at individual projects, not looking at the system as a whole. So the next level is we looking at the optioneering options across the whole system. We're not prejudging which ones are the best. We effectively are setting the system up to then start using the really advanced stuff to say, how do you piece together hundreds, perhaps even thousands of different investments? How do you synchronize those? How do you make sure they're located in the right places? And that's where you start to move into the world of AI. So as stepping stones through machine learning models, through optimization, linear programming models, And then the final piece is once you've done all this analysis, you've effectively got, it's a bit like a sat nav. I always go back to that. You've got thousands of different options to how you move from where you are to where you want to be. But ultimately, you're relying on a system and a combination of technologies to propose an optimal core pathway, and maybe one or two alternatives. But that's not saying that there aren't other ways to get there. It's just saying this is the most efficient route. So that's a lot of what we're doing, is we sort of trying to rationalize all that complexity into one or a small number of pathways, acknowledging that things change. So we help our customers get onto a pathway. And then as we get feedback loops through new data, new assumptions, regulatory changes, policy changes, we then start to course correct, where we say, well, actually, we've committed to this. We can't change course on that, but there are things that we can do going forward that will allow us to get back on track, back onto that optimal route. So, those are the different layers. And then the final piece is the explainability. And this is where, again, we don't have a silver bullet, but we're trying to cut through the different lobby groups around, is hydrogen the way forward? Is electrification? Is it all about electrification? Is it biomethane? Is it heat networks? Everybody's got their view. If you can't contextualize those different views within the overall system, you're going to struggle. So we try and bring an objective view with explainability, and that's where the large language models are incredibly helpful in terms of simplifying these complex trade-off decisions to say, on the whole, a heat network makes more sense there than having lots of heat pumps versus using biomethane as a drop-in replacement for natural gas. So these are the sort of complex decisions, and we're trying to sort of cut through and provide that objective, data-driven, science-based view to facilitate those different parties getting alignment, because ultimately it's not one thing or the other. It's going to be a combination of all these things playing their different roles as part of an overall energy system. And the same is true when we plug in water, we plug in telcos, or we plug in any other sort of infrastructure. They all need to work together to provide that resilient, cost-effective solutions and services.
So is that then where you'd be looking to almost create a prediction, where you sort of almost do scenario planning? You'd be pulling together, you mentioned a lot of emergent energy sources. Could you model what it might look like to have 5% of this and 20% of this, so then you're allowing the operators to understand what the different efficiencies might be? Is that the sort of work you're doing?
That is the sort of work. I'd avoided using the scenario word, but that's absolutely what we do. And we talk about mass scenario analysis. So what we're trying to do, I think the only subtle difference, and again, it's very easy to go down a rabbit hole talking in technical terms, but there's a difference between what if analysis. So if we do this, what happens to the system, versus what's best. And what's best is effectively running through huge numbers of what ifs to effectively get to an assessment of what's best. So to my sat nav analogy, you're not expected to sift through thousands of different options and different alternative routes. It takes you to the answer and says, we think this is based on everything we know, this is the best route. That may change as we go along, but that is the best route, as opposed to saying, if I took this route, how long would it take? And if I took another route, how long would that take? So there's an interplay between, what if and what's best. And that's really what we try and sort of cut through is almost get to the answer and then work back from the answer to say, why does this make sense? What are the trade-off decisions that have been made? Ultimately, there are always some winners and losers, but we try and take a much more holistic view that everybody, if you understand your role within the system, you have some certainty, which means that investment flows faster, it's more productive, and everybody benefits, whether that's domestic consumers of infrastructure services, or whether it's industrial customers, or indeed AI data centers as part of that.
And coming back to data as well, because I think the interesting part for me when you were talking about evaluating these different energy sources or methodologies, I was thinking, well, is there enough data coming from some of those? You mentioned things like what was on biomethane, heat recovery, decarbonisation. They're all at different levels of maturity in terms of the subsectors of the industry. So I imagine imagine, there'll be different players within them who might or might not have different levels of data. And, I'll use the word interoperable, and standards, things like that, they're either are in place if they're more mature, or they're lacking if they're a relatively new and emergent technology. So how do you cope with that race of fragmented picture in order to get to that objective data set that you mentioned is the way you make decisions?
Yeah, and that's really, I suppose, this in some ways our secret sauce is sort of figuring out how you do that in what is a pretty wild environment still. We have different initiatives ongoing around everything from sort of governance through to standards in terms of data sharing, actual data sharing infrastructure in the energy sectors and water sectors. The fact is that we can't wait for that to happen. If it's a sequential thing where you wait for that to happen, we probably be 5-10 years down the track when we're actually seeing that. So that stuff's all important. Our job in the meantime is to help our customers make sense of all this noise and cut through a lot of that noise. What's interesting, I mean, you touched on a couple of things like biomethane. Biomethane is a fledgling industry or sector in the UK, but is really well developed in Europe, where the use of that is significantly more, and the regulation actually encourages it. So, part of that is that sort of techno-economic thing. So, there's a lot of learnings there that we are slow to adopt, and vice versa. Other things that we're good at in the UK that we should be exporting. Again, that is where large language models are really helpful to actually understand all that wealth of information in different places globally that you could actually draw on and make sense of that. You've got technology evolution. We're looking at sort of batteries, liquid sand or heated sand storage of heat being adopted in the Nordics. A lot of the stuff is is incredibly powerful, but there is an information lag. So we're trying to sort of cut through that. And even when it comes to data, a lot of times we are taking unstructured data and creating some sort of a structure for that data as part of this ontology of the overall system. So we're filling in those gaps. The important part, though, is that we're not filling them in and just saying, this is gospel, this is the truth. We're saying, this is where that data came from. This is what we've done to that data to make it useful. But we are not saying that's the only source. If there's a better source or an alternative source, that's really important. And that's just to simplify that example is even in the UK, we have umpteen different views in terms of what the demand forecast or demand curve is going to look like for energy, for example. So, you could put in one demand signal and get a very different set of recommendations to another demand signal. But being able to compare that quickly is really useful because you start to see what are the low regrets or no regrets in the shorter term. So how do you move things on, even though you have that uncertainty moving forward? And that is technological uncertainty, it's pricing and supply chain uncertainty, it's policy and regulatory uncertainty. So this is not an exact science. This is around trying to make sense and put forward the best view in terms of what it could look like, and then being as adaptive as possible. And that adaptive piece is also critical. We've moved beyond the world where you can, on an annual basis or every 5 years as part of a regulatory cycle, make decisions. This needs to be a constant evolution as things change. What is the impact of that? What is the feedback? How do we course correct as we go along? So, massive challenge, and that's what we love. This is a technological challenge, but it's also a social challenge, and it's also an economic challenge.
Yeah, it's fascinating to hear the challenge and how you're applying technology to solve that. I wanted to go back to understand a little bit about how you're actually using LLMs as well, because you mentioned that a couple of times. I imagine you're not just using it like we would off the shelf, just putting questions into ChatGPT or Claude or something like that. And I wanted to hear whether you're using things like RAG, or how you're actually sort of keeping the data that you're and the predictive data that you're generating. How do you then how does that develop and evolve over time? Because presumably that's part of your core IP as well.
Absolutely. So I think the way, I explained our view in terms of those different layers of how you actually build up the overall solutions that we focus on. I think the way you could really view it, and this is more and more the way we're moving, is effectively an agentic framework where you have agents operating at all those levels. In some cases, doing very discrete things like go and harvest data around particular topic area where there isn't good availability of data. Let's say that's around a cost curve for new technology. So it could be a cost curve for new battery technology. You effectively using an agent to go and harvest that data and create more structured data around what that cost curve could look like. And so that's an example, a very discrete piece of work. So that's around sort of data collection. Then you've got the ontology. So how do you make sense of how all the interplay between all these different bits of data as part of an overall model? So we have agents working at that level, actually guiding us on shaping the ontology. All of this is obviously supervised. We're not letting these agents loose, but each layer builds on the other. And the important thing is to be able to adapt very quickly. So as you build that up through the predictive, the machine learning models, through the optimization models, through to the agents that are actually doing the explanations. So they're looking at those recommendations coming out, understanding the mathematical trade-off decisions, and putting that into natural language, which obviously we know that sort of LLMs are incredibly good at cutting through that sort of complexity. And then ultimately, you're sort of wrapping that all together as part of an agentic framework, so that as we get better at all those different pieces, we're not building a new system each time. We're just understanding what needs to change. So if we find a new data set, or we realize actually the way we've architected that view of the system needs to change a bit, we don't want to have to manually go through and find all the things that need to change, everything through to front-end visualizations, all the way back to manipulating data. We want that to be as elegant and efficient as possible, but with that level of control. So the agents are actually setting out, these are all the things we suggest you change. Do you want us to go ahead with that? That is all part of the explainability, but it's an agentic framework that effectively we're looking at, supported by things like graph databases, which are perfect for this sort of thing. But with all these things, there's a bit of art in this, should we say? We're figuring it out in terms of how we leverage this. What we're seeing though is just this acceleration, as you would expect, as you start to go more natively AI. Right from the foundational elements, everything gets faster because we're doing less in the way of documentation because it's self-documenting. We're doing less in the way of or less time-consuming things around testing. As we change things, how do we automate the testing of that? How do we automate the deployment of changes, through our development environments through to sort of productive sites for our customers? So it's across the board, really, Tim, and.
Yeah, there's so much happening within this space, but both in terms of the challenges you're facing, but also in terms of the new technologies which are emerging, which will allow you to kind of provide better solutions there. So what are the things which you're sort of most excited about as you look into 2026, both in terms of maybe the opportunities to make your industry, the sort of the infrastructure industry, as it were, more efficient, but also the technologies which you're seeing emerge, which might help you to do that?
Yeah, and I think, I suppose, in my position, I've always got to balance the sort of technology excitement, which you can probably tell, there's this as an intellectual challenge is incredibly exciting, but obviously we also a commercial business. We need to be able to pay for that. So I think there's a nice tension there between looking at what our customers want and need, what they're ready to absorb at the moment, because this is a journey for them as well. I'm sure, like any customer, they love the idea of pressing a button and getting the right answer. But there's also that reality of how far away we are from that. So, how do we give them the smaller pieces that they really need, that change their lives on a day-to-day basis, and they can really see the value and then build the confidence? So I'm having to balance that on one side, a relatively, digitally and certainly AI immature sectors that we operate in, through to this amazing technology that's available for use. And our job is really bridging that gap to make sure that we're actually delivering the value to customers. We're keeping the wheels on in terms of our own commercial model. And, we're changing the performance of these sectors to unlock that social and economic benefits that we know will come, but we know can be squandered quite easily through lack of coordination, delays, etc. And obviously as a country and even as a region, we're probably not as good as we need to be when it comes to infrastructure. We're seeing a lot of other countries steaming ahead because they have different approaches and maybe different views on how infrastructure should be developed.
Yeah, that's definitely becoming apparent, isn't it? I think there are some, you see it across many different industries. The famous one is telephone, copper wire. The countries which rolled that out first of all, then struggled with the wireless rollout. But the countries across the global south who never rolled out copper wire were able to just get to 4G and 5G much quicker. And I think that's a similar analogy kind of works for a lot of the countries now who are rolling out their infrastructure where they haven't had any AI infrastructure or data infrastructure, but they've got amazing natural resources such as solar that they can plug in. And you see that in the Middle East. So that there is definitely that dynamic there. I wanted to sort of understand a little bit around your sense of the level of maturity within the UK industry that you're dealing with. And I know these are your customers, so you probably need to be quite politic here, but in terms generally, speaking in broad terms, are they more receptive now? Are you seeing that they are being more open to being able to use technology to understand these problems, or are there still quite a few laggards, companies who aren't really understanding the challenges? And maybe it's a follow-on question from that is, what can government be doing, or should government be doing to help to accelerate that?
Yeah, I think it's unavoidable that we all know that things are moving fast, and all our customers are seeing that. The demands on them, whether that's from their regulators, if they're regulated businesses, or from their investors, or some combination of those. So I don't think anybody can ignore the fact that we need to move faster. I think there's also a huge recognition that in order to do that, we need to do things a bit differently, particularly in the sort of infrastructure sectors. It's been very engineering focused. There are, even if you look at the standards, the engineering standards go back decades. They were defined back in the 50s and 60s. They aren't necessarily fit for purpose. So you realize, and even we find this on quite a regular basis, that some of those constraints are not about people. They're about things that have been set out a long time ago that are inhibitors. So part of that is sort of helping cut through that, figuring out what is under the control of our customers and what isn't. And that's where I suppose government and regulators come in as well, to make sure that we are constantly removing barriers that aren't value adding. And that's obviously always a contentious issue, is what is about protecting the customer versus what is something that actually isn't value adding and is just an inhibitor. So a lot going on there. In short answer, there's no question, and obviously that's what's exciting for us as a business, that the demand for these types of services and the step change that you were talking about in terms of approach and actually almost leapfrogging, I don't think it's actually a massive issue nowadays that you are relatively digitally immature, because you have the opportunity to get right up the curve very quickly. You don't need to go through the traditional sort of crawl, walk, run type of approaches. There's an opportunity to adopt some of these advanced technologies and move along very quickly. So I think we're seeing all those things. There's definitely no shortage of appetite. I think there's maybe an understanding and a confidence that still needs to be earned, and that's a big part of what we're doing and have been doing for the number of years now, is building that confidence. That's hard to shortcut, to be honest, and I suppose for us it's a bit of a competitive advantage beyond the technical tools, is also that confidence that our customers have that we can bring something new, but that we can deliver. Because it's pointless getting excited about stuff and then falling at the first hurdle. That just sets you back further. So it is about confidence. It is about taking everybody along with you, and that includes, you know, the regulators, the new system operator in the energy sector as well, that is only just getting up to speed. So, yeah, all these things coming together, frustrating at times, but overall incredibly exciting in terms of the role that we can play within that within these sectors.
Yeah, yeah, yeah. Great stuff. A lot which will happen over the next few years, as all of these systems start to, uh, well, I suppose, expand, innovate, digitize. You know, there's a lot of transformation happening right now. We're going to have to wrap things up there, Michael, but it has been fascinating to talk to you. But just as we wrap things up, I wanted to understand, how can we stay in touch with BMA, understand what you're working on?
Well, obviously, sort of through the normal challenges, the channels. I think we're also involved in a lot of innovation work with different funds, you know, Innovate UK through both Ofgem and Ofwat as the regulators. So that's, a lot of that is in the public domain. You know, people can see that. But yeah, I suppose yeah, our approach is very much around sharing our knowledge. So, you know, I'm more than willing to just have a conversation around these things, as opposed to, you know, looking for a sales pitch the whole time. I think a lot of this is around, you know, sort of building knowledge and like I said, building confidence, and then the success will come from that. So more than happy to you know, speak to any of the UKAI members as well as non-members, you know, as part of that journey. We
Amazing.
all learning together, I suppose, is the point.
Yeah, and thank you. I think that collaborative approach, that knowledge sharing, is really important. And as we're trying to sort of build out those ecosystems across the UK, we need to be able to learn from each other, because things are happening so quickly. And it's no longer the case that you could actually just afford to live in those silos, because we have to share. I mean, we covered it in many different angles, but that, whether it's sharing the data, whether it's sharing the technology, all of those things will help us all to improve our game. So, Michael, we've covered a lot of ground there. It really has been fascinating to see how you're using technology to bring together these solutions, which are going to help to make infrastructure more efficient, and obviously that will benefit all of us. I particularly like the way you were talking about building confidence there as well, because I think that's the key part of what data should be about. Is, you know, it's objective, but it enables people to have the confidence to be able to make better decisions. And you're doing that really well through taking that huge complexity that we talked about, with the scale and the speed of everything that's happening within infrastructure, and you're helping to simplify it in ways that humans can make those decisions, which then again kind of breeds that confidence. So it's been yeah, really interesting to chat to you. Thank you so much for joining me today.
Thanks, Tim. Look forward to further conversations.